Today I'm going to talk about a simplified regex problem. I've actually seen this on sites at multiple places, and so I think this is like a very good practice problem, and I'll show you sort of what the bar is to get a new grad software engineer job at companies like Facebook, Google, YouTube, Instagram, etc. Okay. Amazon, sure, why not? All right, so like first let's just try and understand the problem, or let's state the problem. Basically, we want to implement a subset of regular expressions um, with just the wildcard character and the clean star. Um, and so you might be saying, oh, I don't know what a regex is. And this is where you can try to just really understand the problem and just try and understand uh, like the different subcases. So typically your interviewer will give you some subcases, but in the case that they don't, you should definitely clarify, and even if they do, ask a few subcases. So in this case, the interviewer was super kind. The interviewer is me, so we start with the empty string. So if the target string is empty and the regex is also empty, we return true, right? Because it matches. If it's just a single character, it matches. Um, in this case, A matches with A, and the wildcard character matches the B. And so we return true as well. Um, Here we return false. They're not the two strings. Um, uh, as we process it, we match on the first two characters, but we can't match the third character on the regex. In this case, the wildcard character matches the B, and then the star character um, uh, takes the wildcard, repeats it, and it matches the A. So we do get a match. In this case, we won't get a match because um, uh, we can't match the C at the end, even though we have a wildcard character followed by a clean star. Okay, so before I even really start coding, the first thing I try and do is just um, try and understand the problem and try and figure out like the hardest part. So um, if there wasn't the clean star, the asterisk, this problem would be pretty easy. So uh, given a target string and a regex, what we could do is we could just say, you know, here I'll just all right. So um, I uh, I think it's pretty like basically we can just use recursion to parse each letter one by one. If the first letter matches, we keep or sorry. If the target string and the regex are both empty, we just return true. Otherwise, we will look at the first character on each string, and then if the regex is a wildcard, it matches everything. So we uh, just match the substring, the next substring. Otherwise, we need to check whether they actually match. And so if there is a match, then we just advance one and we match the substring, basically everything after the first character. Okay. So typically, I actually wouldn't even code this. I would sort of just look at it and be like, oh, okay, I don't think the wildcard character is the problem, is like the hardest part. I'm fairly confident I can solve this problem without the wildcard character. The actual hardest part is this clean star. Um, and again, I sort of have like experience, so I'm like, okay, this is string parsing, and it seems like it's solvable via recursion. So let's try um, uh, solving this hardest part. Just at a high level, like understanding how to solve the hardest part, which is the clean star. So I like to think about it in like terms of a subcase. So uh, yeah, let's think about it in terms of like we have this original case. How can we reduce it? So because we have an initial match, because we have this like wild card, we can just well, number one, like there is the star, right? So the star could be 0 or more. So we could just sort of ignore the star and we could do um, this would be one subcase, okay? It's only one subcase though, um, and obviously it doesn't work. The alternative is because we do have a match, um, we can define it like, or the pseudocode would be like first match, you know, and so does that sort of make sense? Basically, um, when we encounter the wild star, we can either just um, ignore it, ignore the. I mean, sorry. When we hit a clean star, when we see a clean star in the second position, we can either just sort of ignore it and just move on, continuing parsing, or we can, which is this first case here, or oops. Or if there is a match on the initial first characters, then we can remove the first character. So already I'm kind of seeing a um, recursive relationship, which would be something like, um, which we might be able to express as like, you know, there are other subcases, but in the event that if length of, oops, if the length of our regex is greater than equal to 2 and the second position is equal to a star, then we can return f of t. We can just sort of, we can try the subcase where we recurse and we just advance and say, hey, the clean star, we're going to use it for the case where we match 0 of the preceding characters. Or we have a first match and we um, uh, advance the target string by 1, and we keep the clean star because we're saying, hey, we're using a clean star and we're going to match at least one of the preceding characters. Um, and so this first match, like how might we define it? It's actually pretty easy. What we can do is something like this. Okay. Otherwise, we return false. Well, that's all fine and good, but we should also probably check that, if lane t is greater than 0 and lane re greater than 0. And we can turn this into an AND statement as well. Yeah, we can do something like this. Return false. Yeah, so in order for us to have a first match, both strings have to have a length that is non-zero. All right, so this is our first match function, okay? Um, and from before, we sort of already had the case where we don't have the weird um, the where we don't deal with the clean star. So we can just sort of add it in and be like, hey, if the length of the regex is greater than or equal to 2, you know, and literally we're just sort of copying over we're literally just translating the pseudocode from above, lines 14 to 17, to actual code on line 29. And you can see that it's like not particularly crazy. And yeah, so we dealt with a clean star. Um, then we dealt with we deal with the base case where the length of the strings are 0, and then we deal with like the subcase where we don't have a clean star, and it just reduces to like this really simple where you just have normal characters and the wildcard character. And so, I've obviously seen this problem before, so I'm able to solve it pretty quickly. Um, but uh, like, let's just run through some cases, and I probably have some mistakes somewhere, and we can debug. And there you go, I have some bugs somewhere. So that says line 34, and I believe it. Okay, that's true. Let's do something more crazy, like oh no, string index out of range. So we go to line 33, we have some sort of issue. Okay, so we actually are not dealing with a case where um, so in the case where yeah, so in the case where we've sort of run out of only where one side is empty and the other side is not empty, we should return false. Now you might be saying, what about let me first. Okay, so that works. So you might be saying, oh, what about this case here where we have a clean star? Well, that's actually already covered here. So what this will do is there's no first match, so it will reduce the above code into, or this subcase into which matches our base case here. Yeah. So obviously I did that really, really fast uh, because I wanted to give you guys the like streamlined version. Um, but I think it goes to show you how powerful recursion can be, and just really focusing in on the solving the hardest problem uh, in pseudocode, and then how like quickly you can translate the pseudocode into actual code. So in an actual interview, you'll have about 45 minutes to work on the problem, and you can literally just spend 30 minutes going through pseudocode with your interviewer, and being like, hey, how's this sound? How's this sound? How's this sound? How's this sound? Um, and so we now have like a working version of the code, and they'll probably ask something like, hey, what's the big O of this? And you'll see that actually in the worst case, um, we are advancing the regex by 2, and we have to test by advancing the regex by 2, and then we have to test by advancing the string by 1. So that's actually, I think, about like O to the 2 to the n. It's pretty gnarly, which is not good. Um, but you can do some stuff to really optimize the performance through memoization. Um, and memoization sounds really fancy. It's often used in dynamic programming, but really all it's doing is, hey, like we've already solved this problem. Let's not solve it again. That's literally it. Like um, let's literally just cache the solution. So a good example of that is um, let me think of one. Um, uh, is this going to be a situation where we reduce to the same? Oh, yeah, I think this works. Okay, so let's just like in the example here, let's say f of this. All right, this will actually reduce to f of a and then dot star. Okay, or because we have like a first match, we could do f of and the second case, you can imagine that it'll encounter a subcase where it's like, and in the first case, so actually, like if you think about it, the first case can reduce to something like this, and the second case will also call a recursion use with the same parameters. And so really, you're like solving the same problem twice. And so what we can do is we can memoize it and just say, hey, like we can create a memoized dictionary, and then we can just sort of store the results. And so an example would be like, hey, like memo if memo.get. So like if we've seen this problem before, then we just return the memoized problem. Otherwise, what we can do is whenever we encounter a problem, we can say like, hey, this is the result. And we can do the same on line 38, 40, and 42, and 43. Basically, whenever we're about to return, we memoize the result, we store it in our little dictionary, and then before we actually return. And then what will happen is whenever we encounter a problem, we will just go into our look at our memo, and if we've solved the problem before, we just return the result. So that's it for just sort of solving this problem. I'm going to I'll probably do a follow-up video if you guys want on how to like to walking through an actual example of memoization. And this is actually why I think using recursion on interview problems is so effective, because you really get to minimize the lines of code. And if you do have like performance issues, you can actually very easily like formulaically improve the performance through a really simple memoization scheme, basically just taking a dictionary and uh, um, using a dictionary to memorize the result. That's it. Cheers. Oops.